Hello everyone, this is Brian Orlasan Cordova and welcome back to another calculus class, and our topic for today is differentiation rules. So I'll discuss yung first 7 theorems or the differentiation rules for the algebraic functions. So number 1 is the derivative of a constant function. So a constant function f of x is equal to a constant c. So ang derivative niya is equal to 0. So let's prove this. So given the differentiation process, so the derivative of the function f of x with respect to x is equal to the limit of the function f of x plus h minus the function f of x all over h, where h approaches 0. This is equal to the limit of c minus c all over h as h approaches 0 because the function, kahit anong input niya, is equal to that c pa rin. Okay? So, constant yung value niya, hindi nagbabago. So, kahit ano pang input ng function, c pa rin siya. So, f of x plus h is equal to c, and f of x is also equal to c. Okay? Then, this is equal to c minus c is equal to 0 over h. And as h approaches 0, magiging indeterminate siya, 0 over 0. But, this is equal to 0 since h only approaches 0. So, may value pa rin siya, pero palapit lang na palapit sa value ng 0. And 0 over any value or any real number is equal to 0. Since the graph of the constant function is equal to c, is always at y is equal to c, and its slope is 0. Okay? So, ito siya. So, ang hinahanap natin dito is the derivative, which is actually the slope of the curve or the line. And it is always equal to 0 since ang function ay may graph na horizontal line. Y is equal to c. So, ang slope niya ay laging 0. So, this is true since the derivative is 0. So, examples, number 1, given that f of x is equal to 3, so ang derivative nito or f prime of x is equal to 0. Number 2, y is equal to 2. So, the function y is equal to 2. So, constant din siya. So, y prime or the derivative of the function y is equal to 0. Number 3, given that z is equal to negative 1 over 4, so ang derivative ng function z in terms of x is also equal to 0. Number 2, derivative of identity function. F of x is equal to x itself. So, ito yung y is equal to x. So, the derivative of the identity function, f of x is equal to x, is equal to 1. So, let's prove this. Given the differentiation process, the derivative is equal to the limit of the difference quotient. So, substituting the values of the input dun sa function, so yung f of x natin, given that x plus h yung input, siya din yung output natin. So, x plus h minus f of x is equal to x. So, minus x all over h. So, we can cancel out x minus x. And performing the limits, so yung value ng h approaches 0. So, h over h na lang ang matitira. Okay? And it is constantly equal to 1. So, kahit anong value ng h, it is always equal to 1. Kahit pa mag-approach siya sa 0, so 0 over 0 is indeterminate, pero ang kinukuha lang natin is the numbers approaching 0. So, it is equal to 1. So, since h is arbitrary, it's always equal to 1. So, yung h over h is equal to 1. Also, the slope of the graph f of x is equal to 1 of the identity function has a slope of 1. Example. Number 1, given that f of x is equal to x, so the f prime of x or the derivative of the function f of x is equal to 1. Number 2, function g is equal to y. So the derivative of the function g in terms of y is equal to 1. So yung y is the variable na fino-focus natin. Number 3, constant multiple rule. Given that f of x is equal to a constant c times x, where c is a constant, the derivative of the constant multiple is equal to c times the derivative of x, which is equal to c only. since we know that previously, yung derivative of the identity function is equal to 1. So, matitira lang ay yung multiple na c. So, as a proof, following the differentiation rule, substitute natin yung given function. The function of x plus h is equal to c times x plus h. And f of x is equal to cx. Since there is a common factor sa numerator c, pwede nating ilabas. So, matitira na lang ay x plus h minus x. And following the limit rules, yung constant multiple c can be put before the symbol of limits. So, matitira is limit of x plus h minus x all over h, which is equivalent to 1. So, dun sa ating previous theorem. C times 1 is c. So, therefore, the derivative of a constant multiple where function of x is equal to cx ay equal lang sa constant multiple c. Example, number 1, f of x is equal to 2x, and number 2, y is equal to x over 2. So, sa number 1, following the differentiation rule, f prime of x is equal to, so i-put up natin yung 2, kopyahin na natin constant multiple, and perform the differentiation ng variable x. So we have 2 times derivative of x is equal to 1, so 2 times 1, which is equal to 2. Dito naman, sa number 2, y is equal to x over 2, so kunin natin yung 1/2 as a constant multiple, and ang matitira is the variable x. So the derivative of the variable x is equal to 1 also. So we have y prime is equal to 1/2 only. Number 4, sum or the difference rule. Just like in limit laws, if u and v are functions of x, then the derivative of the sum or difference of u and v is equal to derivative of the function u in terms of x plus or minus the derivative of v in terms of x. So as a proof, let's say that the function y is equal to sum of functions u and v. So kapag nagdagdag tayo ng increment ng y sa function y, magdadagdag din tayo ng increment ng u sa u at increment of v dun sa v. So mag-change yung function depending on the increments. Since y is equal to u plus v, so substitute natin yung y is equal to u plus v plus delta y. So we can cancel out since pag nag-transpose tayo, magiging negative ito against ito. Then ito magiging negative din against dito. So ang matitira is the increment of y is equal to the increment of u plus the increment of v. And kapag divide natin dun sa delta x, para makuha natin yung ratio, slope of the second line from the definition, and taking the limits of this ratio as delta x approaches 0 is the same with taking the limits of ratio of delta u over delta x as delta x approaches 0, same with delta v. So this is actually equal to the derivative of the function y in terms of x is equal to derivative of u in terms of x plus derivative of v in terms of x. So the derivative of the sum is equal to the sum of the derivatives of the two functions. Example, if u is equal to 2x and v is equal to x over 2, then the derivative of 2x plus x over 2 is equal to the derivative of 2x plus the derivative of x over 2. And since ito ay nakuha na natin on previous examples, so 2 times the derivative of x plus 1/2 the derivative of x. We have 2 plus 1, which is 5 over. Number 5, product rule. So the derivative of the product of the two functions u times v is equal to the function u times the derivative of the function v in terms of x plus v times derivative ng u over dx. So in short, we have u dv plus v du. So minsan dinidisregard na yung denominator na d of x. So it's in terms of x naman lagi yun. So as a proof, we have the finding the derivative using the differentiation rule. So substituting the given functions. So ang input natin is x plus h. So we have the product of u of x plus h times v of x plus h minus u of x, v of x. To manipulate this, kailangan natin magdagdag ng iba pang terms na equivalent sa value na 1. So, ang idadagdag natin is the sum and difference. So, minus u of x plus h vx plus u of x plus h vx. So, same term, pero magkaiba yung sign para equivalent lang sa original expression. From here, you can get a common factor dun sa dalawang unang term. So, ang common term sa kanila, or the common factor here is u of x plus h. So, matitira is v of x plus h minus v of x. So, doon pala makakakuha na tayo ng pwede nating kuning derivative. And doon sa last two terms, the common factor is v of x. And what will remain in the numerator would be u of x plus h minus u of x. Taking the limit of the sum, so ililimit din natin yung product ng first term. Ganun din sa second term. So it is equal to the limit of u of x plus h times the limit of v of x plus h minus v of x over h plus the limit of v of x minus the limit of this one. Where yung limit ng u of x plus h as h approaches 0, so this approaches 0, and this one is actually a definition for the derivative of function v, and this one is vx lang din. Ito naman ay definition din ng derivative. So we have u of x times the derivative of the function v of x plus v of x times the derivative of the function u of x. So that is equal to function u times dv over dx plus v times du over dx. So that's a proof. So example. For 1, given that f of x is equal to 5x squared, which can be shown as the product between three factors, 5 times x times another x. So dito, pwede nating hatiin 5x times x. So following the product rule, we have 5x as your u. So ito yung u and ito yung v. So we have u times dv, which is derivative of x is equal to 1, plus v, which is x, times derivative ng u, which is yung constant multiple na lang. So we have 5x plus 5x. So we have 5x plus 5x. So we have 10x. Number 2, if the function is equal to the product of 2x plus 3 and x plus 1. So, set natin, this is your u and this is your v. So, we have f prime of x, or the derivative of f is given u times dv, which is the derivative of x plus 1. So, derivative ng 1 is 0, so derivative of x is only 1. Plus, we have v times derivative ng u, which is v constant multiple 2, since constant 3 is equal to 0. So we have 2x plus 3 plus 2x plus 2. So distribute ito. Then, combining similar terms, 2x plus 2x, we have 4x, then 3 plus 2 is 5. Number 6, quotient rule. So the derivative of the quotient, or the division of two functions, u over v, is equal to v times du over dx minus u times dv over dx over square of v. So ang notation natin dito is low, or yung lower function, low, the high, or the derivative of higher function, minus high, below, meaning derivative of lower function, over low or low squared. So, lower function squared. So, pwede nating ilagay I times low minus low the high over the slow. So, as a proof, following the differentiation rule, so substitute na natin yung functions. The derivative of the function f of x is equal to, ang input ay x plus h, so u over v, x plus h minus u over v of x, so all over h. So cross multiply natin and get the BCD. So ang gagawin natin is itong h ay i-multiply na natin sa denominators. So we have u of x plus h times v of x minus u of x times v of x plus h over v of x plus h times v of x times yung denominator na h. Okay. So from here, kagaya ng sa ating product rule, so dun sa numerator, mag-a-add tayo ng terms na equivalent sa 1. So, minus v of x times u of x plus v of x u of x. So, equivalent ito sa 1, hindi nagbago yung value. But, kagaya ng process sa product, common term dun sa first two terms is v of x. So, we have v of x, matitira u of x plus h minus u of x minus. So, dito, ang common term is u of x. So, nilabas natin and we make it negative. Para ang matitira sa numerator would be a positive v of x plus h minus v of x all over h. Okay? And yung h natin dito is i-dedicate na natin doon sa pwede natin kuhanan ng definition ng derivative. All over v of x plus h v of x. So taking the limits of each terms and factors, so we have limit of v of x times the limit of a difference quotient of the function u, then the limit of u of x minus times the limit of the difference quotient ng function of v, all over the limit of v of x plus h times v of x. So as h approaches 0, so sa denominator, magiging 0 na to. So matitira ay v of x times v of x, which will result into v of x only. So ito ay derivative of the function u in terms of x minus the function u, kaya naman siyang h, times derivative of the function v in terms of x, all over v of x times v of x, which is v squared. Example, number 1, the derivative of 5 over 3x in terms of x. So we have, yung u natin dito is 5 and v is 3x. So we have v is 3x. So you lower times derivative of higher, which is derivative of 5 minus high is 5. Then below, or derivative of lower function, 3x over low 3x square. So performing the derivatives ng 5 and 3x, we have 3x times 0 since this is a constant, and 3x constant multiple rule. And sa baba, we have square of 3x is 9x square. So the 0, we have negative 5 because we cancelled out a factor 3. So matitry negative 5 over 3x square. Number 2, we have the derivative of 2x plus 3 over x plus 1. So following the quotient rule, we have x plus 1. The high is derivative of 2x plus 3 minus high 2x plus 3 below, or the derivative of x plus 1, all over lolo, or x plus 1 squared. Performing the derivatives, we have x plus 1 times 2. Derivative of 2x plus 3 is 2. Derivative of x plus 1 is 1. Then, distributing the factors, we have 2x plus 2 minus 2x plus 3 all over x squared plus 2x plus 1. Then, combining similar terms, we have 2x minus 2x, and 2 minus 3 is negative 1. So we have negative 1 over x squared plus 2x plus 1. Number 7, power rule. The derivative of x raised to n is equal to n times x raised to n minus 1. So as a proof, let's say function y is equal to x raised to n. So if we add increment of y or delta y, dun sa ating input naman, dadagdag tayo ng increment of x. So y is equal to x raised to n. And expanding this binomial, so we have x raised to n plus delta y equal to x raised to n plus n times x n minus 1 times delta x plus n times n minus 1 over 2 factorial times x raised to n minus 2 times delta x square plus so on and so forth up to delta x raised to n. So it is a binomial expansion. Then, kapag din-transpose natin itong x raised to n sa kabila, magma-minus ito. So we can cancel them out. So what will remain is delta y is equal to n times x raised to n minus 1 delta x plus the whole expression. Then if we divide is by delta x, so maka-cancel out yung delta x. Then ito magiging raised to 1. And this one will be 1. So we have n times x raised to n minus 1 plus n times n minus 2 over 2 factorial x raised to n minus 2 delta x plus so on and so forth delta x raised to n minus 1. And if we take the limit as delta x approaches 0 or h approaches 0, is taking the limit of this expression. Now if delta x approaches 0, all terms na may factor na delta x approaches 0. Okay, so what will remain is the derivative of y, which is equal to x raised to n, is equal to n times x raised to n minus 1, which is yung natiraang first term. So examples, we have derivative of x raised to 5. So let's follow the rule. So bring down sa harapan yung exponent, which is n, 5. Then times x raised to 5 minus 1, have 5x raised to 4. Number 2, we have derivative of 3x squared. So following the rule, we have 3x squared. So we have constant multiple is pwede nating ilabas na and perform the power rule x raised to 2. We have 2 exponent and x raised to 2 minus 1, which is 3 times 2 is 6 and 2 minus 1 is 1. So we have 6x only. Number 3, we have derivative of 5 over x cubed. So pwede nating itaas yung denominator as a negative exponent. So we have the derivative of 5x raised to negative 3. So performing again the power rule, so yung 5 is a constant, so pwede natin ilabas. And negative 3 yung n, so we have negative 3. Then x raised to negative 3 minus 1. We have negative 3 times 5 and negative 3 minus 1. So we have negative 15x raised to negative 4. Or, pwede natin ibaba uli, since naka-negative yung exponent, we have negative 15 over x raised to 4. And that's all for today.